All right, class, let's take a look at example 3. Now, in this case, they want a polynomial that represents the area of the entire region. So let me just highlight this portion here. And, well, we could do this one by parts. So for example, if we just concentrate on region A, region A represents a square whose sides are x and x. So the actual area will actually be equal to x squared. And in this case, it'll be unit square. We can add the units later. Region C represents a rectangle which has sides of x and y. So area is equal to x, y, technically units squared as well. Region B, it's another rectangle, not to scale, and it has x and y, so its area is equal to xy units squared. And then the last region, in this case region D, it's a squared, not to scale, but let me fix it. It's a squared, whoops, I think I made it worse, with length and width of y's. So the area is equal to y squared units squared. Okay, so let me just express the total area. So total area is going to be equal to, well, technically x squared plus xy plus another xy plus a y to the second. And we can simplify this one since we technically have like terms. So we're looking at x squared plus 2xy plus y to the second. And technically, because, well, we're looking at an area, this one will have units squared. And they don't mention what type of units, so we would just rewrite it as units to the second power. So that's going to be the polynomial that represents the region in terms of the actual letters that are given, x's and y's. That's it for this one. Let's move on to problem 4, which is very similar. And they also want a polynomial, but in this case, they're looking only for the shaded region. So let's actually obtain the total region. So total region. So when you look at the total region, you're looking at the large square that has y and y. So the actual area is equal to y squared, also units squared. Okay, and then if we look at the smaller regions, in this case, let me call this A, B, C, and D. And let me write it as region A, B, C, and D. All of these are rectangles. Actually, they're squares of the same size. So the size of these are going to be x and x. So the area is equal to x squared. But for the 4 pieces, we're going to get 4x squared. Okay, and the 4x squared represents, well, the sum of this area, this, all the rectangles that I wrote as A, B, and C. Now, the important part here is to get the area of the shaded region. So let me rewrite it as total. So the total area of the shaded region can be expressed as the total region, in this case y squared, minus each of the squares, which in this case it'll be 4 x squared, and technically it'll be units to the second power. I'm always putting units on all of these because they represent a specific length. And for another problem, they may want us to evaluate a specific x or y value. That's actually it for these two problems. I'll put the rest on another video.